In this chapter, we begin our discussion about bonding. You can see up here the definition of bonding. It's a general word for just joining or attaching two or more atoms in a stable arrangement. And when we talk about bonding, if you recall, the protons in an atom tell us what element it is, but it's the valence electrons or the outermost electrons that are involved in bonding. So in this chapter, we'll be talking quite a bit about the valence electrons. Now, before we get into this chapter, which if you look at the chapter title is Ionic bonding, let's kind of compare the two big categories of bonding right here. So there's ionic bonding, and this is what's going to be in chapter 3. And the word ion, an ion is just a charged particle. And when we talk about an ion or a charged particle, there's going to be two charges that we can have. We can have a positive charge or a negative charge. And so in ionic bonding, we have ions that are positive and negative. Now, how we get positive and negative electrons is this sentence right here. The electrons are transferred from one atom to another. So we'll find out in just a minute that when you lose electrons, you become a positive charge, and when you gain electrons, you become a negative charge. Now, who likes to do this? What elements? Metals and nonmetals will form together ionic bonds. So if we were just given a formula, and I think there's a homework problem like this, where it just has the formula. If it's a metal, which remember on the periodic table, if I did a rough sketch of the periodic table, there's a stair-step line over here, and this side of the line are metals, except for hydrogen up here, not this guy, and then this side are nonmetals. So metals and nonmetals together, when they bond to form new compounds, their electrons are transferred and they form ionic bonds. The second type of bonding is covalent bonding. Now, covalent bondings, they form, you see right here, molecules. And a molecule, this is just a unit of atoms that is uncharged. So these atoms don't have, they're bonded together, but they don't have any charge like the ions, because ions have charge. And how that happens, if you look here on the second place, the electrons are shared. So both of these things involve valence electrons, like I mentioned up here. But in ionic bonds, the electrons are transferred to create ions. And in covalent bonds, they're shared to create molecules. And if you look here, the type of atoms that like to form molecules are metals and metalloids. So they're on this side of the periodic table. So they're closer together on the periodic table. So really simply looking at the periodic table, you might take common things like a sodium chloride, and we can identify sodium chloride as ionic because sodium is a metal and chlorine is a nonmetal. We could also take something then like water, H2O, which has two nonmetals, and so then this is something that is covalent. So initially we can just identify things as ionic and covalent by what elements that are involved. So now this chapter is ionic compounds, so we're really going to be focusing on these charged particles up here and how they form and how they're attracted to each other. So this first part of the lecture is just really about how these ions form. So here's the definition of ions that I wrote over there too. Charged particles formed by gaining or losing electrons. Now remember, the charge can be positive or negative. And if we look right here, an important idea about charge is that opposite charges attract. So opposite charges attract and like charges repel. So what it means is if I have a positive charge and a negative charge, it would be like a magnet and they would attract each other. So when we have positive and negative, this first one, cations, these are positive charge. And how I remember, this is my little trick, the T I kind of see as a positive. So cations are positive ions, and look at this, they're formed by losing electrons. Now let me give you an example. So sodium, I'm going to erase something over here so I can write my example over here. Okay, so let's talk about ions. So sodium, if you look on the periodic table, an atom, it has an atomic number of 11, which means it would have 11 protons and 11 electrons, because we know for an atom, they're equal. Now, if I told you that sodium likes to lose one electron, and we'll learn why in a little bit, it still has 11 protons, that's because it's sodium, but now it has 10 electrons. So think about it. I have 11 positives and 10 negatives. So if I added those two together, I would have an extra positive. And so this becomes a sodium ion. Now because there's a 1 positive, I write an Na+. If there were 2 positives, which there could be extra, then we would have a 2+. But when there's a 1, we don't write a number. Okay, well and I kind of worked my way into a smaller corner, but let me talk about the negative ions then, which are called anions. And I think of anions as A, and then the N makes me think of negative, and then the word ion. So anion, I think of a negative ion. And negative ions are formed by gaining electrons. So if I have an oxygen atom, and oxygen has a atomic number of 8, which means it would have 8 protons and 8 electrons, because in an atom, protons and electrons are equal. Well then, if I told you that oxygen likes to gain 2 electrons, and we'll learn why, then what happens is I still have 8 protons because it's oxygen, but instead of 8 electrons, I have 10 electrons. So think of it, now I have 8 positives and 10 negatives. If I put 8 positives and 10 negatives, I'm going to get 2 negatives left over. So my ion is O with a 2 negative charge. Now in negative ions, we'll see later, but the name is not called an oxygen ion. In negative ions or anions, they change the ending to IDE. So O2 negative is called an oxide ion. So sometimes it's counterintuitive. Positive ions are created by losing electrons, and negative ions are created by gaining electrons. Part of it, what you have to keep in mind, is electrons are negative. So if you lose electrons, you become positive because you're losing negative. If you gain electrons, which are negative, then you become negative. So how can we predict, like on the previous page, I mentioned that sodium likes to lose one, and oxygen likes to gain 2. And so then the question is, how can I predict that? Well, how I predict that is using something called the octet rule. Now here is the definition of the octet rule. It says that main group elements, that's anything with an A, will gain or lose electrons to have the electron configuration of a noble gas. Well, you might ask, why would they want the electron configuration of a noble gas? And that's because the noble gases have a complete valence shell. So if I wanted to write here, I've done it in the next one. Let's look at these examples. Okay, so here I've written the electron configuration for sodium. And if you don't remember electron configurations, you might want to review it. And then right underneath it, right here, I've written the one for neon. Okay, now let's compare it. And if we compare neon, if you notice, the only difference between sodium and neon is this one electron, the 3s one. So that's why sodium likes to lose 1. So it will lose the 1 electron, so just imagine that it's gone. And then if you look at its electron configuration, it looks like a sodium. Since it's lost an electron, it does have a positive charge now. But that's how we predict the stable ions for sodium, is that we know that it would like to lose that valence electron so that it has the same configuration as the noble gas closest to it, neon. Now oxygen was the other example I did for you. So here's oxygen and here's its electron configuration. Now, if I look at neon, which is the closest noble gas to him, what you notice is if I compare, the only difference is that oxygen has 4 valence electrons right here, and neon, or 4 in the P, and then neon has 6. So if I add 2 electrons, 4 plus 2 equals 6. And now the oxide ion right here, which is the stable ion, looks like neon. So how I think of it is that the atoms like to dress like the noble gases. So they're not becoming noble gases because their protons aren't changing. However, they are having their electrons by gaining or losing. Their electrons in the valence shell are looking like the noble gas closest to them. And that's the octet rule and what drives the atoms to form their stable ions. Now, we can relate these charges to the periodic table. So thank goodness we don't have to go through every element and draw it all out and figure it out. We can relate the charge on the ions to the groups. So we're talking about the main group. So here's the main group. There's the groups right there. And we know that the group number of the main group is related to the valence electrons. So you'll notice group 1A has 1 valence electron. And we talked about this in chapter 2. I also do not include 4A because it doesn't usually form ions and its pattern is not quite as helpful to us. The noble gases are also not included because they're already stable with 8 valence electrons. So we don't predict that they form ions. So what you do is if from the up to here, so for 1, 2, or 3 valence electrons, what you'll notice is that the atoms will lose their valence electrons. And so here's some examples. So if you have 1 valence electron, you lose 1. If you have 2 valence electrons, you lose 2. If you have 3 valence electrons, you would lose 3. So everything in group 1A, so sodium would have 1, potassium would have 1, lithium would have 1, rubidium would have 1. So the nice thing is I can predict the stable charge simply by the group number, right? So I can look in the group and know that group 1A all has +1 charge. Now after you go past the middle in 4A, and then if you look at the bottom ones, so 5, 6, and 7, they're getting closer to the noble gas that's to the right of them, and so instead of losing electrons, they gain electrons. So when they gain electrons, then they form a positive ion. So when I look, let's look at group 6A. You see here, so 5 will gain 3 to have 8, 6 will gain 2, 7 will gain 1. So if I looked at group 6A, I could say, all right, they're going to gain 2. So oxygen, sulfur, see how it works, selenium. So instead of having to memorize all of the different possible charges for the main group, we can relate it to their position on the periodic table thanks to the octet rule. So here if I were to draw a periodic table, just a rough one. Oops, sorry. Okay, so let me write the group numbers. So we have 1A, 2A, then we have 3A, 4A, 5A, 6A, darn it, 7A. This is, oops, sorry. This is 8A. Oh, sorry. 8A. So there they go across, and all I have to do is not memorize every ion, but know that group 1A likes to form a 1+, likes to lose 1. Group 2A, 2+. Group 3A is a 3+. 4A, honestly, down at the bottom, some of them form a 4+. These usually up here, which we would predict to form negatives, we'll talk about in just a minute, we don't really see as ions. And that's why they're not included on this table here, because it's not really something we see very often. Then 5A, now once I get to the middle, so it's 1+, 2+, 3+, you can think 4+ or minus. Now we start the -3-. So these guys are 3-. These guys are 2 minus. These guys are 1 minus, and then the noble gases are 0. So I kind of think of it like stair steps. So it's 1A, 2, oops, I started too soon with my stair steps. 1A, 2, oh no I didn't. 1A, 2A, 3A, 4A, 5A, 6A, 7A. If you want to have an 8A, you could, and it'd be 1 plus 2 plus 3 plus 4 plus minus 3 minus 2 minus 1 minus, and then 8A would have no charge because they're stable. So what you need to focus on is the trend on the periodic table. So if you know you had aluminum and aluminum's in 3A, that you would predict its charge as a 3 plus. Or if you have chlorine and chlorine is in 7A, then you would predict its charge as a 1 minus. Remember, the periodic table is something that we have and will use. Now in general, here's some big generalizations. So our metals, which are on the left-hand side of the periodic table, remember? So they're on the stair steps lines here, and they're on this side. Our metals form cations, and cations are formed by losing electrons. So we expect the metals to have a positive charge. Even the transition metals in the middle are going to be cations. We can't predict their charge like we were, but they're all cations. The nonmetals, so that's a smaller group, it's up here in this top corner, they tend to be anions, and they are anions because they gain electrons. And here it says transition metals are harder to predict because of where their electrons are located, but I will give you a list of transition elements when we're working on it, and that will be something you'll kind of get used to. So for your class, you don't have to memorize the transition elements. So think about the definition of ions, what causes ionic bonding, how it's different than covalent bonding, and work on understanding how the periodic table can help us predict the stable ions.